Hi, this video is about the branch and bound technique. Branch and bound design technique. So the idea of branch and bound is basically make the possibilities tree but use bounds, whatever that means, to prune it. So for some problems this can be very effective, and the ones we're going to attack shortly that you'll be looking at in class is the 0-1 knapsack and the traveling salesperson problem. But first we want to look at, we're going to try to do this TSP. This is embedded exercise 41 on page 74. So we're going to try to do this using the B&B idea. Okay, so suppose we have a graph with these weights. So of course the weight from any vertex to itself is 0, and then we just have 3, 1. So these are more or less pretty random numbers. I just wrote down some when I made up this problem without any particular thought. Okay, so now let's build the tree. Okay. So the idea is we start out with a node 1, and then one possibility is to use the second vertex could be 2. But now we're going to put in here the cost. So the node format is going to be an important idea as we move on. When you do branch and bound, every node has to have enough information that it can decide how to deal with its children, how to produce its child nodes. So at this point, vertex 1 to 2, that partial tour or path that's trying to be a tour costs 3. So a really important idea, if we were doing, when we did brute force, which is what the possibilities tree gives us, we would go ahead and try 1 to 3 and 1 to 4. So we would go level by level, and when we got to the bottom, the first time we saw a tour, we'd be almost done with the whole tree. So instead, we're going to use depth first. So this is a common idea on branch and bound, although we use more sophisticated. When we actually get to our real stuff, we'll use best first. So of all the nodes in the possibilities tree we've created, they'll all have bounds, which is a magic number that sort of indicates how good they are. And we'll always follow the one that has the best bound. It's the best bet. So this is what gives, we use the word heuristic. Heuristic is where you don't have a deterministic for sure correct algorithm. You just rely on probabilities and luck to end up with the right solution in an efficient way. So from this node, the next thing to do would be, we don't have any bounds here, all we have is the cost. So at this point we would just naturally do 1, 2, 3, and 1, 2, 3 would cost, so we add to the cost of the previous path, we just have to add on 1 notch. So we need the length weight from 2 to 3, which is 6, so we end up with 9 here. So this edge from 2 to 3, at 6 added that. And then we're actually done, because the next path, there's no choice. The next thing is 1 to 2 to 3 to 4, which costs, so the 3 to 4 node edge costs 5, so that gets us up to 14. And then we can just say, oh, that's a tour. So the tour costs 25. So here's the tour info. So why 25? Because 4 back to 1 costs 11. So 11 plus 14 is 25. Okay, so at that point we know, as we continue building the tree, if we ever get a node with a cost more than 25, will know to stop and not keep trying to do better, because it can't. As we go down in the tree, these numbers just increase. But, so in this we'll do depth first means back up to the decision point, and on this very small case, the next decision point would be to use 1, 2, 4. So 1, 2, 4 costs 3 plus the cost from 2 to 4, which is 4, so that's 7. And from there, there's only one choice in the possibilities tree, 1 to 2 to 4 to 3, and the 4 to 3 costs 2, so that gets us up to 9, and then that gives us the tour. There's no more choices, so the tour is 1 to 2 to 4 to 3 back to 1, so we add on the cost of 3 to 1, which is 9, so we get 18 for that tour. So at this point, this is unimportant. This branch, which gave us that tour, is unimportant. We now know if we ever get to a node with cost at that point bigger than 18, or equal to 18 for that matter, then we just stop. So now we back up, and so now the backtracking takes us all the way back up to here, and we do 1 to 3. So 1 to 3 costs 1. And then we go 1 to 3 to 2, kind of going smallest vertex number first. And 3 to 2 costs 8, so we're up to a cost of 9 at that point. And then we're done. There's only one possibility, 1 to 3 to 2 to 4. And 2 to 4 costs 4, so that's up to 13. And then we put on the edge back from 4 to 1, which costs 11, so we're up to 24. So that tour is no good. So as we back up to here, and we'll instead do 1 to 3 to 4 at a cost of, let's see, 3 to 4 is 5, so that's 6. And then we have no choice but to do 1 to 4 to 3 to 2. And the 4 to 2 costs 6, so that's 12. And so we throw in the cost to go from 2 back to 1, which is 2, so we have 114. So that's our winner at this point. And the other guys are, we found them, did a lot of work to find them, but it's no good. Oh, I might have done something wrong there. 1 to 3 to 4 is 6, 12. 4 to 2. 4 to 2 costs what? Oh, 2 back to 1. 2 to 1 costs 2. Yeah, when I did work this out before, I got 13, but I was wrong. Which is too bad for this example. So now as we backtrack, the only choice is up here to go from 1 to 4, which costs 11? No, costs 7. And then from there, one choice is 1 to 4 to 2. And 4 to 2 costs 6, so that's 13. So before, when I thought this was 13, I could just stop there. But we actually have to go on, which is sad. So 1 to 4 to 2 to 3, so 2 to 3 costs 6, so we're up to 19. So at that point, we prune, because we're doing worse than this guy, so we can't possibly. That can't possibly be the winner. So then we go back to 1 to 4 to 3. 4 to 3 costs 2. So that gives us 9 at this point. And then the only possibility is 1 to 4 to 3 to 2. 3 to 2 costs 8, so that's 17. So we can stop thinking about it, because that's already so this is the best tour. And the problem is solved. So sadly, except for these very mild prunings, this didn't work. But with a better example, you can imagine that the first tour would have been small enough that we could stop. If the first tour we found, or the first few thousand tours, was really good, then the ideas in the rest of the tree. So you start building the tree, and you're building quite a bit, and you find a really good tour, and then the rest, you hope, the idea of branch and bound is that most of the other paths don't have to go too far before they realize they can't possibly beat the one you found. So that's the idea of embedded exercise 41. Thanks.